It's an exciting day here in Algebra 2. Today we are moving on with our systems unit and we are looking at how to solve three variable systems. There are three ways that we can do this. It does not involve graphing, I promise, but I'm going to walk you through each way in a separate video so that it's not rushed and you can just skip ahead and move on as needed. So 2 points determine a line, which is why we were able to graph them on a grid. 3 points determine a plane. This requires three-dimensional graphing, which we're not going to mess with. But one thing to note that's different here is your answer will be in ordered triple because instead of just x and y, you now also have z. So with solving these by hand, we also have the same two techniques. We have substitution. Here, let me move my camera. We have substitution and we have elimination. Substitution is when you select one variable to isolate and you plug it into the other two in the system until you are down to a two-variable system, which is easier to solve. So when we are trying to figure out which equation to get a variable by itself in, firstly, I like to number my equations so that when I'm referring to them, I know which one we're talking about, you know which one I'm talking about, and vice versa. So looking at these equations, in equation 2, I can see x does not have a coefficient, so I could very easily move over the 3y and the 3z to the right side of my equation and get that x is equal to negative 3y plus 3z plus 3. Now what I'm going to do is take this whole expression and substitute it in place of x in equation 1 and equation 3. What this will do is now give me two equations that only have two variables, y and z, which is more manageable. So starting by plugging this into equation 1, negative 3 times negative 3y plus 3z plus 3 plus y minus 3z equals negative 9. I have to distribute that negative 3. That's going to give me 9y minus 9z minus 9. And then out here I still have the plus y and the minus 3z. Now I can combine all of my like terms. 9y and y gives me 10y. Negative 9z minus 3z gives me negative 12z. And I want all my constants to be together, so I'm going to add 9 over here. Well, negative 9 plus 9 is 0. So what I'm going to do is call this new equation I have written equation A. Again, this is just so we can keep track together of who has done what, and it's not going to be a big deal. Okay, so now I need to do the same thing but plug this in for x in equation 3, so that's going to look like 7 times negative 3y plus 3z plus 3 minus 2y plus 3z equals 3. That's going to give you negative 21y plus 21z plus 21. And then outside I had minus 2y plus 3z. And now I can combine all of my like terms. Negative 21y minus 2y is negative 23y. 21z plus 3z is 24z. And then if I move the 21 to the other side with subtraction, that will give me negative 18. So this simplified equation I am now going to call B. Between equations A and B, I'm down to two variables, x and z. Sorry, not x and z, y and z. And looking here, I can now decide, do I want to use substitution or elimination to proceed? Well, if I look at 24z and negative 12z, these are two terms that I could get to cancel if I were to multiply equation A by 2. And remember, that means you have to multiply all three parts. So that will become 20y minus 24z equals 0. And now when I combine these equations, negative 23y plus 20y gives me 3y. These cancel to 0, and I get negative 18. Well, now I can solve for y by just dividing, and I get that y is negative 6. Now that I know y, I can solve for z by plugging that back into equation A, equation B, or my doubled equation. But we like to look for smaller values where you're less likely to make a mistake. So looking between our three options, I think equation A is the best. You would get the same answer if you had done it with a different one, though. So that's going to look like 10 times negative 6, because that's what we know y is now, minus 12z equals 0. I'm going to shift my camera down so you can see. 10 times negative 6 is negative 60. If I add that to the other side, negative 12z is equal to 60, which when I divide both sides by negative 12, I get that z is negative 5. which leaves us to our final portion, which is to solve for x. And I am looking back at my work really quickly, back to when we found y. Negative 23y plus 20y was negative 3y. So I'd have needed to divide these both by a negative, which means y would have been positive 6. And then when plugging that in here, this would become positive 60. So negative 12y would be negative 60. Negative divided by a negative would become positive. So doesn't change the numbers, just the signs, but that's still important. Okay, now that I know y and I know z, I'm going to go all the way back to equation 2 where we got x by itself and use that to solve for x. So way back up here, I know that x is equal to negative 3 times y, which we found to be 6, plus 3 times z, which we found to be 5, plus 3. So that's going to be negative 18 plus 15 plus 3. And what do you know? That all adds to 0. So we know x, we know y, we know z. We just need to give our final answer as an ordered triple. So in order, 0 is x, y is 6, and z is 5. There is our final answer. Okay, let's do that once again. Looking at example 2, again, I'm going to number my equations so that we all know what we're looking at. And I'm going to go ahead and just draw a little line here to separate my work. Looking through here, I think equation 2 is going to be the easiest one to get a variable alone. And that variable I want to get alone is y because it has a coefficient of 1. So if I'm going to rearrange equation 2 to get y by itself, what that will look like is y equals negative 5x minus 3z plus 6. What I did is I added y and then added 6. So now this is what I am going to substitute in place of y in equation 1 and in equation 3. So starting with equation 1, I'm going to have 2x minus 2, and then this is where I substitute our y, plus 3z equals negative 9. I have to distribute that negative 2, and I'm going to get plus 10x plus 6z minus 12. Still have that 3z on the outside. Then I can combine all my like terms. 2x and 10x gives me 12x. 6x and 3x gives me, z gives me 9z. I'm going to add the 12 to the other side, and this will be equal to 3. I'm going to call this equation A. Now I am going to do the same thing, plugging this in for y, but in equation 3 instead. So negative 7x plus 5 times negative 5x minus 3z plus 6 minus 3z equals negative 8. So distributing that 5, I get negative 25x minus 15z plus 30. Now I need to combine my like terms. Negative 7x minus 25x is negative 32x. Negative 15z minus 3z is negative 18z. And if I subtract the 30 away, I get negative 38. And I'm going to call this equation B. Now, looking at what I have here, between A and B, I have a 9z and an 18z. Again, I could get these to cancel if I double equation A. So when I do that, I have to multiply all three parts. I'm going to get 24x plus 18z equals 6. And when I combine those two equations, negative 32x plus 24x is 8x. This adds to 0, and that's going to be equal to negative 32. So when I divide both sides by 8, I get that x is negative 4, which I can now use to solve for z in either equation A or equation B or my doubled one. Equation A, before I mess with it, has my smaller number, so I'm going to go with that one. 12 times negative 4 plus 9z equals 3. That's not 24. That is going to be 48. Negative 48 plus 9z equals 3. If I add the 48, that means that 9z is equal to, I do apologize, I made a similar mistake again. Negative 32 plus 24x would be negative 8. So when you divide the negative by a negative, this would become positive. So positive 4 gives you positive 48. 3 minus 48 gives you negative 45. dividing both of those by 9, z, gives you negative 5. So now I know x and I know z. I can use that to solve for y. So y is going to equal negative 5 times 4 minus 3 times negative 5 plus 6. So that is negative 20 plus 15 plus 6, which adds up to 1. So my ordered triple in order, x was 4, y was 1, and z was negative 5. So that concludes our video and lesson on using substitution. I am now going to record a separate one for elimination.